In this video, we'll examine percentages dealing with retail markups and markdowns. Now let's start with some terminology to understand what does markup and markdown mean. A markup is a price retailers increase on a good to make a profit. They buy it at some wholesale price, they mark it up, that way they can guarantee they're making money. Whereas a markdown is a price they will decrease a good so that they can sell it. Maybe they've held on to it too long. Often you'll see these called discounts. So markup is what they're marking up a product after they've bought it wholesale to make profit. Markdowns are their discounts to sell it and get it out of the store. Now we can look at this with two basic formulas. With a markup, to figure out that retail price, we take our wholesale price and then we're going to add the percent of markup times that wholesale price. Whereas a markdown, we would find the sale price by taking our retail and subtracting that markdown percent times the retail price. Now, another way we can think about this is using that formula that is over of equals percent over 100, but think of it in terms of this type of problem. What is the new price versus the original price? And that's going to equal our percent out of 100%. Now, what does these terms mean? We'll go through some examples to help out. But when we talk about percent, that is 100% plus or minus that change. That's important. So like when we talk about a markup being 30%, the percent we would put into the formula would actually be 130% because it's the 100% plus the markup. If it was a markdown, we'd be saying 100% minus the markdown. So 40% sale would mean that we're going to really be looking at a 60% problem here. So let's look at some examples to help us understand how to determine markup and markdowns. So in this first one, a store buys athletic shoes at a wholesale price of $50. The store marks up the shoes 70%. What is the retail price that the store sells the athletic shoes? So first, let's start with just the very basic equation that we had, where it's a retail price will equal the wholesale price plus the percent markup times the wholesale price. So we're adding on that percent that is being marked up is really what's happening here. So let's start by highlighting the key pieces of information in this problem. We need the retail price. Here it says, what is the retail price? That tells us it's unknown. We need to determine that. Next, let's look for the wholesale price. There's a problem that says the wholesale price is $50. So wherever there's wholesale price in this equation, I put the $50. So right here is 50 and right here is 50. Last thing it says we need is the markup percent. And it says we mark them up 70%. So I put a 70% here. Now I have my equation and I see that I'm solving for the retail price. First thing I do is I change my percents to decimals and then I multiply so that 70 hundredths times $50 equals $35, and then $50 plus $35 is $85. So the retail price for these athletic shoes would be $85. Now what if I use the other formula? So I'll keep the first one here so you can see how we set that one up. That will allow us to compare as well. So in this case, when we talk about the new price and the original price represents that wholesale, where we started. The new price becomes our retail, what we're trying to sell them for. So let's start there. The new price, we don't know because what is the retail price? We do not know. Then the original price is our wholesale price. We know our wholesale price was $50. Our percent change, the markup of 70%, we have to remember we're adding that to 100. So we're selling them for 170% of the wholesale price. Now we have our equation and we can solve it several different ways. Some of you might have learned to cross multiply divide, but we can also multiply both sides by 50. Then we can see that 50 divided by 50 simplifies to 1, which will leave me with x, and then 170 divided by 100 is 1 7/10. 50 times 170 equals 85. So the amount is still the same. And if we look back to this equation here, this is 100% plus 70%. So in essence, I am doing 170% times $50 here as well. It's just I've broken it into the two parts with the distributive property. Let's look at another example of how markups could be done. A store sells a pair of jeans at a retail price of $36. The store marks up the wholesale price by 60%. What is the wholesale price the store pays for the jeans? So here the difference is, especially when we look at our equation, we're not solving for the retail, we're trying to figure out what was that wholesale. So what we're solving for changes in the problem. That's why it's important to first highlight our information and plug it into our equations to help us out. So we are told the retail price is $36, so I can plug that into my equation here, $36. The wholesale price, it says what is the wholesale price? That's unknown. So anywhere that I have wholesale price in my equation, I put an X, which would be here and here. Last thing I need is my percent. I marked up 60%. So now when I write my equation, I have $36 equals X plus 60% of X. Now I can't deal with percents in an equation. I have to change them to their decimal form. So this would become 1x plus 6/10 x. And 1 plus 6/10 gives me 1 6/10 x. So that's a very key step right there, is understanding to change the percent to a decimal so that I can add my two unknowns. Now I can divide by 1 6/10. On the right hand side, 1 6/10 divided by 1 6/10 simplifies to 1. And then when I divide $36 by 1 6/10, I get $22.50. Now in your calculator, it'll come out as 22, a decimal, and then just the number 5. But remember, we're dealing with money, and money has 2 decimal places. So you have to make sure that in your answers you put 2 decimal places. So we would say a store pays a wholesale price of $22.50 for the jeans. Now, if I wanted to go to the other method, same process though. The new price is retail, the original price is my wholesale. So retail at $36, wholesale is unknown. The percent is still 100 plus the 60%, because it's 160% of the wholesale price. Now when I multiply both sides, you can do the cross multiply and divide, or I can say I multiply both sides by x. So x divided by x gives me $36 equals, and then again, 1 6/10 times x. Look, it's the exact same place. So it's a matter of what method makes more sense to you. Use that to help you solve the problems. I divide both sides by 1 6/10, and I end up again at $22.50. Now what if I looked at markdown problems or discount examples? So say a hiking store is having a seasonal sale where all sleeping bags are 35% off. If one of the sleeping bags has a retail price of $87, what will be its sale price? So here it's a markdown, and in a markdown I have my sale price equals the retail minus the percent times the retail. So I'm subtracting out that markdown. So let's start with, do we know our sale price? In this one, what will be its sale price? So no, we don't. The retail price, well here I'm told the retail price is $87. So I'll plug it in here and here. Last thing I need is my markdown percent, which is stated right here as being 35% off. Now I can take 35% and multiply it by $87 by multiplying by its decimal form of 3500ths. So I'll be subtracting $30.45 from 87 to give me $56.55. So I know the sale price of the sleeping bag would be $56.55. Now I can use the other option as well. This is how we did it first. Now let's compare it. Here the new price is our sale price, and the original price is what would we have sold it for retail. So new price is always that change, and the change in this case would be the sale. So do I know my sale price? No. Do I know my retail price? Yes. Do I know my percent change? Yes, but it's a discount, which means I'm decreasing from 100, and that's the key part to remember. I'm subtracting the 35% from 100. So that means that the sale price is 65% of the original price. Now I can cross multiply and divide, or I can say multiply both sides by 87. That would simplify to 1 on the left side, and then I've got $87 times 65 hundredths, which would again give me the same price as before, $56.55. So no matter how I'm going, I'm still getting to the same place. And here, this would be 100% minus 35%, which is 65% of $87. Now let's look at another example. Say a television's on sale for $126. If it's 30% off the retail price, what was the original price? So here, I know the sale, and I want to know what was the original. I can still use the same equation though. I just substitute in what I know. I know the sale price, $126. What was the original price? So I don't know that retail price. I'll put in X for both places. The markdown percent, well, it's told 30% off. So now I have $126 equals X minus 30% of X. Well, I can't deal with that in the equation, so I change it to its decimal form. So this would be 1X minus 3/10 of X. And again, I always put that 1 there to help me remember to add and subtract it. Now, 1 minus 3/10 is 7/10, so I can divide both sides by 7/10. That's telling me that this is 70% of the original price. So my original price would have been $180, which means that the television originally cost me $180 if I was to buy it at retail. Now, let's look at it using the other option. So in this case, again, new price is sale, original price is the retail. That's where it started, and now it had this markdown. So always think about the action, and the action that it leads to is your new price. So again, the sale price, that's that action, $126. The original price, the original retail where I started, not sure. The percent markdown, again, was 30% off. So I started at 100% and I removed 30%. That's telling me that what I'm really looking at is 70% of the original cost. Now I can multiply both sides by X, or I can do my cross multiplication depending on what you feel comfortable with. Here I'm going to multiply both sides by X, so that the left side becomes $126. And again, look, I'm at the same place. Divide both sides by 7/10 to get to that $180. So whether you use the formulas written as an equation, or you like to use the ones that have the fractions to cross multiply, do what makes the most sense to you.